so when we look at atmospheric concentrations, which is the really important thing from the point of view of climate change, we see we're at record levels. So right today, we're at 421 parts per million. When I was born, it was 317 parts per million. And pre-industrially, it was 280 parts per million, just to give you a scale, some indication of how substantially we've changed that. So we've added 50% to atmospheric concentrations of carbon dioxide through human activity. In the case of methane and nitrous oxide, they're also at record levels. In the case of methane, we're almost up to triple the pre-industrial levels of methane. And methane is a big gas, and it's really important from agriculture. And so when we look at what's actually going on, we don't see any foot being taken off the climate change accelerator. Instead, we actually see the foot continue to be on it. So given that we've known for, since the 1820s, if we put out greenhouse gases, we'll warm the Earth, it's not surprising with all of those gases we're producing that we've actually seen a warming Earth. And this is a graph straight from the IPCC reports, which shows the sort of orangey colours is the best estimate of temperatures arising both from the human influences and the natural influences. And you can see that's well above the curve, which is down below the sort of greeny coloured one, which is just the natural influences alone. And you can see that natural influences, they go up and down, volcanic activity, some variations in solar activity can contribute to variations in global temperature, but effectively the natural system, if left to its own devices, would be pretty much flatlining in terms of temperatures. But when you add that human influence through greenhouse gas emissions and land use change, we see that sustained increase, which matches very closely to the observed increase in temperatures, which is the main line through that. And so when we look at the temperature increases across the globe on a decadal average, a 10-year average, we're up to about 1.1 degrees. If you look at a trend basis, we're up to about 1.2, 1.24 degrees. And most people don't have any idea whether 1.24 is big or small. I'm telling you here, it's really big. The temperature difference between the last degrees, we're actually talking about a quarter of an ice age's worth of temperature change, but obviously warming rather than cooling, which is what ice ages do. And so 1.24 is big. It's really, really big. In the last ice age, as an example, at 5 degrees cooler, our sea levels were 120 metres below where they currently are. So the ocean was way further east from here than we currently see. We're right out to the sort of the continental shelf. And so that's what 5 degrees does. It fundamentally changes the face of the Earth. It gives you kilometres of ice over parts of North America and Europe. So 1.24 mightn't sound much, but it's really big. When we're talking 3 degrees, which is where we're currently heading with our greenhouse gas emissions, that's like 2/3 of an ice age. So that's the scale of change we're dealing with. It's really, really non-trivial. And so not surprising, given we're warming the Earth, we're also seeing lots of other things changing, including, obviously melting of Greenland and melting of Antarctic ice sheets, warming of the oceans, which expands the oceans and raises the sea level, etc. And I'll talk some more about this later. But in all cases, there's very, very explicit links to human activity and climate change. Now, is Australia different from what is going on in the world? And no, is the short answer. This is a graph straight from the Bureau of Meteorology, which shows temperatures, and you can see that sustained increase in temperatures, which is very common to what's going on everywhere else in the globe. And some places are going up faster than we are, some places are going up slightly slower, but you can see that sustained increase. If you look at the most recent year, last year on this graph, you can see the big influence of La Nina on that. So La Ninas tend to cool Australia and they cool the world. And you can see that last year, 2021, was much lower than the trend line. And so that's just variability caused by El Nino and La Nina. And so that sort of is looking at the average temperatures. But the real important thing I think that people miss is the extremes. So the things that really hit us bad aren't the averages, it's the extremes. And if you say, instead of looking at average temperatures across Australia, you look at the extreme temperatures, you get an even more dramatic picture. And so what this graph shows, again from the Bureau of Meteorology, it shows the area of Australia which in any given year is experiencing really, really hot conditions for that particular location. So it's the 10 percentile hottest year in our baseline period. So the Bureau of Meteorology's baseline is 1960 to 1990. And so it's a really hot year according to those baselines. And you can see if you go back 100 years, relatively little of Australia in any given year was experiencing one of those really, really hot conditions. But if you come to current years, the running average is about 60% of Australia is experiencing really, really hot conditions, and some years are up to almost 100%. They're in the 90% sort of range. And again, you can see the big influence of La Nina in the most recent year, much, much lower than the long-term average, but we still have about a fifth of Australia is experiencing really hot conditions, even in a big La Nina. So we can see that the extremes are just going up and up really quickly, and this is a really important message. Now, when we look at what's happening right across the globe in terms of impact, so it's not just, climate change is one thing, but the thing we're really worried about is how does it impact things that we value, like agriculture or biodiversity or water supplies or electricity supplies, etc. And this is a graph straight from the IPCC Working Group 2 report. And what it shows is each of these coloured areas is a study which shows the impact of climate change due to human activity. And you can see, regardless of where you are, whether, every ocean, every continent, every island is impacted already by climate change. We don't have to wait for 30 years or 50 years. It's happening already, and it's pervasive right across the place. There's impacts. And some of those impacts are incredibly significant in my view. So this is a map which shows the effect of climate change already in terms of reductions in agricultural productivity compared with what would have otherwise happened. So if you look at that map in Australia, so we're around about 20% is what that shows. So that means that in the absence of, so I should describe the method here. So what they've done is they've taken agricultural statistics from countries across the globe, and they've used various techniques to take out the management signal and the technology many places is pulling down yields. And so this is what that graph shows. It's the pulling down element of the climate. And what this shows is that with a couple of exceptions, like the old USSR and Canada, everywhere in the world is actually already being negatively affected by climate change in terms of agricultural productivity. And that number for Australia, around about 20% reduction, is also the same as it is for the globe. So there's a precursor to this study was done by Embers in Canberra, part of the Department of Agriculture, and they found across Australia there was about a 22% reduction in agricultural productivity due to climate change. So the sort of alternate reality here is that in the absence of climate change, we would have been producing 22% more than we have been. And if you're a farmer, you'll know that if someone waved a magic wand over your farm and said, I can give you 22% more productivity, you'd be pretty darn happy. It's huge. And that's what climate change is already doing. It's huge. And of course, Australia is being impacted, but we're not the worst impacted. If you look at Central America, big parts of Africa, parts of Southeast Asia, their sort of numbers are in the 30s and up to 40% reductions, which is massive. So if you actually think about it, in the absence of climate change, some of those, probably most of those billion people who on a day-by-day basis don't have enough food to eat, probably would have enough food to eat. In the absence of climate change, we probably wouldn't have kids starving in big parts of Africa. You can see how those parts of Africa, which tend to be the ones that are on our news, you know, with big famines and things, are also those ones where climate change has hit hardest. So again, the message is we don't have to wait for climate change. It's here already, and it's here big time. This is really, really non-trivial stuff. Now, if we look forwards at what some of the emission changes that we might implement and how they might translate to temperature changes, this is a graph from the Working Group 3, the emission reduction part of IPCC. And what this shows is different scenarios of greenhouse gas emissions over time. And so if we look up on the top left, where we're sort of a flat area, that's our historical emissions moving into the future emissions with those coloured curves on the right. And the basic message is, if we're to keep temperatures down to 1.5 or 2 degrees, which is the Paris Agreement goals that we've signed up to as a nation, we have to start right now reducing our emissions. In fact, we have to probably start at, you know, the latest we could start is during that period 2020 to 2025. This study worked in 5-year blocks, and basically says if we haven't started reducing our emissions during that 5-year period at a global scale, there is no way we can actually start to keep achieving 1.5 degrees. And you can see that the sort of scale of changes, that sort of blue curve down the bottom, which is the 1.5 degree compatible curve, requires not just rapid response, it requires very large responses. And when we look at the right-hand side where it talks about the sort of size of the emission reductions, interestingly, their sort of number for emission reductions for 2030 are actually exactly the same as the Labor Party's. And so I know this came before the Labor Party's numbers, but there is a different baseline. So this is operating essentially, I think, off a 2010 to 2015 baseline. Labor Party is obviously operating it for 2005. But the message is we do need, at a global scale, very, very substantial emission reductions by 2030, continuing that down effectively to net zero by 2050 or before. And every year we delay reducing emissions means that number, the emission reduction number, has to be bigger, and the time we get to net zero has to be shorter. So if we delay and dither for another 3 or 5 years, that 43% turns up to 60% or thereabouts. If we delay and dither for another 3 or 5 years, instead of being 2050 being our net zero target, it has to come back closer towards 2040. So delay really costs us, and it's really risky. It puts us in a position where we have to put the brakes on harder than we otherwise would. And so if we want to stick to 2 degrees, obviously things are a little bit more lenient, but nevertheless, we have to make significant reductions by 2030 at a global scale and also at a national scale. And really importantly, when we look at these analyses, going to net zero is not the end point, which you'd assume it is from a lot of the sort of coverage from politicians and business. It's actually a waypoint on a trajectory. You have to actually go below zero to actually be consistent with either 1.5 or 2 degrees. And that's a conversation we haven't yet had the courage to have in Australia, because everyone's panicking about how we're going to get to net zero, whereas in fact we have to go below net zero. We have to suck carbon dioxide out of the atmosphere and put it somewhere safe. And that's an area where Australia could have a great competitive advantage for all the reasons why we could have a competitive advantage with renewables, and we're having conversations about people putting up renewables in this district, but we can also convert that into a competitive advantage in removing carbon dioxide from the atmosphere, not just through biology, you know, through trees and grass and soils, but through technical means as well. At the moment, our sort of emission trajectory is more akin to 3 degrees, but you never know what might happen with you know, global disruptions of different types. But the patterns of change don't change very much if it's 3 degrees or 4 degrees. Just the degree of change, you know, changes. And if we hit you know, something like 4 degrees, obviously you get variation. You know, the temperature goes up faster around the Arctic and Antarctic than it does in the deep oceans of the world. But we're likely to have a lot more extreme events like fires and storms and floods, such as we've experienced in the last few years here in Australia. And if we get these sorts of increases in temperatures, we're likely to suffer a lot more heat stress. We're likely to suffer a lot more issues such as air pollution, because there's often an interaction between high temperatures and pollution that generates increased problems there. We're going to have increased disease burden, particularly water or foodborne diseases, and issues about mental health. So mental health tends to deteriorate, both acute and chronic mental health, depending on climate conditions. And also labour productivity decreases as temperature goes up. So lots and lots of things can happen as a result of temperature, and I'll talk about them in a minute. And of course, there's impacts on biodiversity, natural resource management, and other things which are really important for our farming communities. And if you look over on the right-hand side, that's the picture for what might happen with rainfall. And again, you can see big variations from where you are. If you're in the Arctic or Antarctic, likely a lot more rainfall. If you're in the equatorial Pacific, a lot more rainfall. But for that big band in the mid-latitudes in the southern hemisphere where Australia sits, and southern Africa and South America, we can see reductions in rainfall, but also reductions in rainfall in Central America and the Mediterranean zone. And so a lot of people live in those areas and are dependent on agriculture where those rainfalls are likely to decrease. So when we look at sort of aggregate all of the sort of scientific information about climate impacts, this is an IPCC figure. What this shows is different systems down the left. So the top line with the sort of dots there is the global picture, and then it goes down sort of, continental scale, Asia, Australasia, Europe, North America, etc. And then it goes through a few different systems like cities, the Mediterranean region, and mountains. And then the vertical columns are different sectors. So essentially it's split up into three. On the left-hand side is water and food. Then it's health and well-being, and then it's cities and infrastructure on the right-hand side. And each of those is split into different columns. Now, I've just sort of picked out one column there. Oh, well, I should say, if you look at that, the big picture is really worrying. There is no single cell in that whole table where there's only a plus, where climate change only brings good things. At best, you've got minuses and pluses, where there's some negatives and some positives, but most of the cells only have negative impacts. So the message here, the big picture message from this table is climate change is actually really problematic for pretty much everything we value. And if you look at that one column there, which I just chose, which is heat, so I'll just talk about that a little bit more. You can see that across every sector, every continent, every region that's in this table, there's only negative impacts from higher temperatures. And if we actually think though about high temperatures, it's actually more pervasive than just high temperatures affecting people in cities. If we look on the left-hand side, high temperatures impact on water scarcity, higher evaporation rates, less water, less useful water as well. If we look at agricultural production, higher temperatures means your crop yields generally go down. If you look at livestock production, again, they go down. If you look at fisheries, they go down. Think salmon farms in Tasmania. If we look at infectious diseases in the health, generally speaking, as temperatures go up, infectious disease burdens go up as well. And if we look over at mental health, as I mentioned before, higher temperatures increase mental health challenges in many places. And then on the right-hand side, I'm just having to remember, so that's sort of energy and other sectors, again, impacts of high temperatures. So a single variable such as heat stress or high temperatures has systemic impacts across our systems. It's not just the heat column, because people feel hot when there's a heat wave. It has really, really big impacts much more broadly. And to give you a little bit of a picture of the geographical spread and the severity of this, this is a study done a few years back by Antonio Mora from University of Hawaii. The picture on the top left is the historical frequency of what he called deadly heat stress days. So these are days where the heat and humidity is really high, such that an unprotected human body in doing light exercise outside is at risk of developing heat stress. So that's where your body can't self-regulate the temperature. And so just think Darwin in the middle of the build-up. That's the sort of conditions we're thinking about. And you can see that historically, significant parts of the world had significant heat stress. Top end of Australia, 100 days a year roughly, heat stress days. If we look at the bottom right picture, that's what the heat stress days might look like under a high emission scenario by the end of the century. So big slabs of the world effectively have every day becoming a heat stress day. And across the top end of Australia, almost every day becomes a heat stress day. And those conditions which historically have been experienced at the top end around Darwin now stretch down about half the continent. So really, really big changes in terms of heat stress. And for me, almost bizarre that we can have a discussion, as we have had, about developing the north, but actively excluding climate change from that discussion. It makes absolutely no sense to me. This is a largely because of the environment in which they're living. They just didn't like the heat environment that they were living in. So this is, pervasive in its potential impacts. Now, just so you've got to have some hope that we can do things. What this shows is these are what we call burning embers diagrams. They're a standard product of the IPCC. What they show is different changes of risk with changes in temperature. So in this case, it's a heat stress, and what it shows is different temperatures on the left-hand side going up to 4 degrees. And as those temperatures go up, the colours change. So they go from sort of pale, essentially zero risk, through to yellows, some risk, reds, high risk, and then the sort of purpley colours are essentially irreversible and unmanageable risk. And you see, as we head up towards the 3 and 4 degrees, if you don't adapt, we get into that essentially irreversible and unmanageable space. The size of these bars on the right indicate what happens if we do adapt effectively, and we can reduce that risk. So at any given temperature, we've got less risk, and we can actually push down on that risk in total. And the challenge here, of course, is that for people in places like Australia, yes, we can turn on our air conditioners. We can go down to the shopping centre and cool down there. We can run a bath and hop into the bath and cool down there. But there's vast numbers of people across the globe who don't have those options. And that's why, even though adaptation can be helpful, it's not necessarily helpful for many, many people. And of course, that increases the inequities that are built into climate change. That those people who are likely to be hit hardest are often those people who have contributed least to the greenhouse gas emissions, and they're often the people who have least capacity to deal with the consequences of climate change. So climate change is a big driver of inequities across the globe. It has been historically, and it continues to be out into the future. And of course, one of the big problems here is that if we do instigate responses to heat, such as putting in air conditioners, if they're powered by coal-fired power stations, we just make the whole problem worse. We just ramp the whole thing up by producing more greenhouse gas emissions, which means it gets hotter, which means we have to turn the air conditioner on more often, which produces more greenhouse gas emissions, and you just wind the whole system up. So there's a whole series of things we need to consider, including about responses which are themselves low emission responses, because otherwise we just make the problem worse. Now, just to add a little bit of more salt to the wound, what might happen in terms of water in Australia. So these are, again, a report from a map from the IPCC Working Group 2 report, and this shows the change in runoff per degree temperature change. So if you look down at the Murray area, so it shows minus 19%. So if we say, okay, well, if we're heading towards a 3 degrees world, you multiply 19 by 3, so you get 57% reduction in your runoff in your Murray at a 3 degree scenario. If you look at southwest, it says 54%, It's basically saying by the time you get 2 degrees, you've on average lost all of your water in your system, and a similar pattern happening across pretty much most of Australia, a little bit less so up in the northwest. And you might think that's really extreme, and it is. I mean, it's really worrying. But if we actually look at what's already happened in the Murray, we've already lost about 40% of our flows due to climate change, plus a few other factors. And if we look at what's happening in the southwest around Perth, they've already lost 85% of their runoff due to climate change. So dams which were built to store rainwater are now storing desal water because they just don't fill up anymore with rainwater. And so that's how radically it's changed. And so these numbers could actually be underestimates for Southern Australia. So to me, it's inconceivable that we'd have like a Murray-Darling Basin plan which does not take into account climate change. It's almost mind-boggling in its disingenuity to actually do that or even prosecute that argument. So these are really big changes. And if we think we've got competition in our river systems between different users, agriculture and urban systems, industrial use in the natural environment and cultural uses, we haven't seen anything yet. Like this is going to become really, really savage over the next few years. And if we look at what we call a multi-hazard approach, this is bringing all of those different hazards that I talked plus others together. We produce a map like this. So each of the little maps is a single hazard, such as floods, droughts, fire, etc. And they're all brought together into the big map on the top left. Now, if you look at that top left, and that's essentially the aggregate hazard map, you see that those areas, parts of Australia and the area to our north of Australia, is essentially the global hotspot for increased hazard associated with climate change. So that means that it's highly likely that our defence forces are going to be called out more and more and more to actually do humanitarian disaster relief. Their function is at risk of significant change and is already causing significant stress in the defence forces. If we actually think about our aid program, it is only going to go up because of climate disruption, and the sort of list of risks go on, including things like environmental migration, which is already starting to be, thought through in terms of the United Nations. And again, to give you a bit of a feel for what this means, so a recent study by Wim Thierry and others in Europe tried to get a handle of what this actually means in the lives of people. So what they did was they looked at the number of extreme climate events that a child who's just been born, just a couple of years old now, would experience in their lifetime compared with their grandparents. And the answer they came up with is, on average, that someone who's born now will actually experience 3 to 4 times as many extreme climate events as their grandparents did. So what for their grandparents might have been a once-in-a-lifetime event actually becomes a relatively regular event for these people. And of course, the cleanup costs of that just extend over a period of time. And the thing that we're already starting to see in Australia is they bleed into each other. And if you just look at what's happened in Western Sydney with 3 major floods within 2 years, those events and the recovery bleed into each other. They don't even have time to recover from one before they're into the next and into the next. And that's a really, really scary thought. And the only reason why we're able to actually deal with that in Australia is simply because we're a wealthy country and we've got a lot of money and a lot of support through government and community activities. And that's fine as long as we remain wealthy. And most of that wealth at the moment is through 2 big products, coal and iron ore, and the demand and supply of those is not guaranteed out into the future. So we really need to be thinking hard about how we're going to sustain this sort of disruption into the future. So one of the things that humans always do under different circumstances is we adapt. So we're, that's if you had to actually have a single characteristic which defines humans, it's that we're an adaptive species. We can live everywhere from pretty much the North Pole to the hottest places and driest places on Earth. We adapt to the environments that we find. And so we will adapt to climate change. It doesn't mean we'll be happy doing that, but we will adapt to most of these circumstances. There will probably be massive loss of life in the process. It's not putting a rosy picture on this, but we will nevertheless respond. But the point I make here is if we actually have climate change, which is large and systemic, and what's the other word? Large, systemic, rapid, and net negative, and that's what I've just shown you. You know, that does generate that sort of response. Then the logical response is, in terms of our adaptation, we also need to have adaptation which is large and systemic and rapid and really positive, you know, really forward-looking. And are we doing that? No. In Australia, over the last 10 or so years, our adaptation research in Australia has gone down 75% against trend. Now, instead of ramping up our adaptation responses due to the politics that we've had in both state and federal levels, we've massively reduced our investment. Those people who are actually engaged in that, both in industry, community, and in academia, have moved on. You know, they've taken jobs overseas or they've moved on to other topics. They're no longer working on these topics, and yet we need it more and more right now. And when we look at a global scale, is that unfortunately, what we see is not a coherent response to those climate changes that we've seen. We're seeing a really fragmented and partial response, which is often tweaking existing risk management, so management of climate variability, rather than rethinking this and positioning ourselves to manage for climate change. And so what we're observing is a growing gap between where we really arguably should be in terms of our adaptation responses versus where we are. So there's a big growing gap right across the globe, and there's a big growing gap here in Australia. And so we really rationally should be starting to fill that gap, because not doing so will be increasingly expensive. And we're talking tens of billions of dollars every year or two. So just to sort of flesh that out a little bit in terms of adaptation responses. So in the IPCC, we did a synthesis of all of the studies we could get our hands on, which looked at climate adaptation responses by different sectors and by different regions, etc. And this is the key table there. I'll actually just blow that up so it's a little bit easier to see. So in this particular case, I've just blown up that part of the table which deals with water and food. And you can see there's different systems there. So ocean systems, water security, food security, and against them there's some very big aggregate sort of adaptation responses. And then those little dots on the right-hand side, the first of those dots is the potential feasibility. So is this a feasible proposition, the adaptation responses for that sector? And those feasibility are based on the different dimensions, which are on the right-hand side, which and then there's a dot, which is the synergies with emission reduction, with mitigation. And you can see that different adaptation responses for different sectors have different feasibilities, and there's different amounts of this, you know, from our literature, then in many circumstances you can find adaptation responses which do that. So there is, you know, hope that we can at least take the nasty edges off climate impacts. And if we look at how those match up with the Sustainable Development Goals, so Australian government, along with other governments across the globe, have signed up to the 17 Sustainable Development Goals, one of which deals with climate change. Number 13 is climate change. And you can see, again, for all of those different adaptations that I put on the previous slide, we assess them against the Sustainable Development Goals. So that's these dots here. And you can see in most cases where there was literature to draw from, studies to draw from, there were synergies. So you could actually deal with climate change and improve sustainable development at the same time. So there are good messages out there, but we have to be smart about targeting them, and we have to be active. We have to do stuff rather than not doing stuff, which has been the status quo to date. So I guess and I probably want to wrap this up soon, so I won't go into depth on this slide, but basically just this raises a couple of questions for me, which is, is our research and development investment appropriate at the moment? And the answer is no. It's a tiny amount is being invested into adaptation responses, as well as now emission reduction responses in Australia. And to, again, give you a bit of a flavour for this, is that of all of the international investment on climate responses, that the IPCC estimates only between 7 and 8% of that is actually spent on adaptation responses. The vast majority is on emission reduction, particularly looking at deforestation type responses. And a lot of that hasn't been particularly effective at the best of times. So big questions about how we spend our money, public money as well as our private money. And for me, a big question about are our institutions as they are at the moment appropriate? So when we look at our institutions that do climate change adaptation responses, for example, the research and development corporations, what they tend to do is silo. So the GRDC will do research on the grains, and meat and livestock will do research on the livestock. And so what that does is lock people into existing silos rather than encourage exploration outside of those silos. And increasingly with climate change, I think we have to do the latter. We have to actually expand the option space for people to explore. Now, the last few slides are on emission reduction. And so this comes from the IPCC Working Group 3 report. So that's the mitigation report. And one of the headline sort of items from that was we could actually look at different countries' emission reductions and look at how they're tracking. And across the globe, there's 18 countries who have emission reduction trajectories going downwards, which are broadly consistent with meeting 2 degrees target. There is no country which is going to meet 1.5 at this point. But it's good news, like at least they're going downwards. Of those 18 countries, Australia isn't there. We're not part of that group, which is doing, in a sense, their fair share of emission reductions. And yet, when we look across other sort of dimensions rather than a national scale, we see massive numbers of entities starting to engage on emission reductions. So huge numbers of cities, huge numbers of regions across the globe are active and on a trajectory to reduce their emissions. We are starting to be left behind in Australia. If we can get our act together and get to 43% by 2030, we'll be back within the pack rather than left well behind. Now, I'll just blow this one up just so you can see it. But what this IPCC group did was they looked at a whole range of different emission reduction options, and they looked at the cost of those and the size, the potential capability to absorb or reduce greenhouse gas emissions. And that's what this sort of graph shows. So the different emission reductions are listed down there. So, going to, wind energy, solar energy down the bottom, avoiding, demand management for energy, etc. So there's a whole series of different emission reduction options there. And against each of those, the different coloured bars, the colours indicate the cost or sometimes the benefit of implementing these options. So, for example, when you're looking at wind and solar, is that the vast majority of that, big slabs of that, billions of tons worth of emission reductions could happen at less than $20 a tonne. That's the sort of blue colours. And in many cases, a positive rather than just a reduction. It actually makes you a profit. Once you go to the sort of orange and red colours, you're getting up to the sort of $50 a tonne, $100 a tonne sort of numbers. So more expensive in some circumstances. But that tells us pretty clearly that there's a whole bunch of options across different sectors which can be implemented pretty cheaply. And when you add all of those up, it takes a big chunk out of our greenhouse gas emissions. So we can do, a lot to reduce our emissions with very little cost right now with the technologies we have. We just haven't got the policies and the behavioural change that allows that to happen. And the other real important message here from that working group was, again, if we look at those emission reduction options and compare them with the Sustainable Development Goals, again, in most circumstances, we can identify options that achieve both, that reduce greenhouse gas emissions and enhance sustainable development in things like reducing poverty, improving water supply, etc. And so the sort of message here is if we're smart about how we respond to climate change, we can not only deal with climate change, but we can deal with a whole range of other big issues across the globe. And I think that's actually a really important message. We don't want to silo climate change into its own little box. What we do is integrate it into, improvement in biodiversity, improvement in food production, improvement in water security, etc. So we want to actually have co-benefits that stretch across different systems. I'll just give that a miss, but that was just focusing on the urban area one. And the last point I'd make, because this applies to a whole bunch of agricultural sectors, is that when we look at greenhouse gases, we have to differentiate, in my view, between the targets for different greenhouse gases. So when we look at the dynamics of carbon dioxide in the atmosphere, there is no question that if we want to stop the accumulation of carbon dioxide, we have to go to net zero. That will just essentially level out carbon dioxide. To start pulling it down, we've got to go below zero. We have to take carbon dioxide and go net zero, below net zero. But if we look at, say, methane, we don't have to go to net zero for methane to stabilise temperatures. We have to reduce it significantly by about, say, 60% by 2030, but then we can level that off. And so we don't need to go to 100% reductions for methane. And likewise for nitrous oxide, we need to reduce nitrous oxide emissions by about 30%. Now, if you're in an agriculture system, it's much, much more feasible to reduce your emissions by 50 or 60% than it is to 100%. We simply do not have the technologies at the moment that allow our existing agricultural production and reduce our emissions by 100%. But we can have a pretty good stab in some of those of reducing them by 40% with the technologies we have now. And so differentiating in this way can make those targets from completely unrealistic and problematic for different industry sectors into something that's much more manageable. And so that's probably my last message here, is as we engage more effectively in climate change, we have to find smart ways of doing things. We have to find informed ways of doing things that improve the circumstances of people, that meet the demands for other factors, that give co-benefits to biodiversity and to natural resource management, to water supplies, to health outcomes. And if we do that well, we're going to be in a much, much better position than we otherwise would be. So the message here is, yes, we do have some really big challenges, but at the same time, we've got some really big opportunities to take that on in really constructive ways. So I'll just leave it there and happy to answer questions.
I want to open up for people to ask questions, because I'm sure there are questions that people would like to ask. Maybe I'll start with the first one, and that is, there was a graph up there about water runoff, and it looked grim. But right at the moment, there's a hell of a lot of water runoff going on in some parts of Australia. So how, we know about La Nina and some of the problems with the dipole, linear dipole. But how does that, the fact that the atmosphere is going to have
between averages and variability and your extremes. And it's a question which relates very closely to that. So average runoff. But of course, in Australia, we know that averages don't mean very much. It's very rare to actually have an average rainfall year. So what is likely to happen, and already happening, is that our extremes are getting more extreme. So our droughts are getting worse, but at the same time, our floods are getting worse. And in particular, this is driven by, as the atmosphere warms, it can hold exponentially more water. So if you think of it, the atmosphere as a bucket that needs to be filled up before it rains, If you're in a phase like La Nina, when that bucket fills up and it tips, you get a huge dump. And it's a much bigger dump than you would otherwise have had because of the warmer atmosphere. And so that's what's happening. We're getting more extreme floods because our buckets are bigger. And so when they dump, they really give us a lot of rainfall intensity and a lot of problems. But at the same time, if we're actually in a dry phase, like an El Nino phase, having a bigger bucket is a real problem because it takes a lot more to fill it up. So the periods between it raining are actually extended. And when it does rain, your evaporation rates are much higher and your temperatures are high because water on our landscape cools our landscape. And so you end up on the one hand sort of spiraling out towards more floods, on the other you spiral down towards drier conditions. And so the really important thing, as I emphasized it before, is not so much the averages, it's what happens to our variability, our extremes. And the indications at this stage are that the El Nino conditions are going to become more disruptive. So the La Ninas are going to get wetter in our part of the world and the El Ninos are going to get drier. And the Indian Ocean dipole is going to strengthen its influence. And one of the differences in there is that it seems that the analysis is once we take our foot off the climate change accelerator, that Indian dipole response will disappear fairly quickly. So that will revert to historical sort of conditions, but El Nino will continue for quite some time before it starts to settle itself down. So we're in for a rough ride is the message. Not just the averages are going to go up, but the variability is going to go up.
Okay, so if you've got questions, speak up nice and loud. So who's got a question to ask? Has anybody got another question?
We've got a question or two from Zoom, and I'll try and disperse them with audience questions so we don't interfere with everything. I think this is the first one from Len, looking at the map. I should turn on this other mic so maybe I've got a chance of people hearing the question. We have Len saying, so Russia tends to benefit from climate change overall based on what you're seeing. Is that a correct?
So the question was, does Russia benefit more from climate change than the rest of the world?
Yeah, so that map showed what's already happening in agriculture. So it didn't show what's happening in other sectors. And again, it's treating the whole country as a single blob, you know, of agriculture stats. So there are probably some people in Russia who would welcome a bit of warming. So if you live in Siberia, but Siberia and parts of that area just a year or two ago experienced their first more than 40-degree day ever recorded. They've experienced the worst fires they've ever recorded. They've got the tundra melting and so the permafrost is melting, and so their buildings and their roads and their foundations are destabilizing because, you know, if you built it in solid ice, it was really stable. But once you melt that, your buildings and everything just, you know, start to collapse. Big increases in some insect-borne diseases because of the warming conditions and things like that. And so, a short while, but there's also big sectors of their economy that are going to or already are starting to see really big costs. And so again, you sort of need to delve into the detail to get a bigger picture. But I think it's too simplistic to say, you know, Russia and Canada will benefit because I think there's going to be lots and lots of surprises, which will actually be quite the opposite.
Yep, not one. Well, something. Yep.
Just today, there was an example of how difficult it's going to be to set levels. There's a lot of flooding down the Hawkesbury, a lot of flooding. And all these calls are out for, we must reduce the amount of water that's held in Warragamba. So the recommendation from some of that, we should maintain it at 60%. Now, I mean, normally in a dry time, when it gets to 60%, we start to panic a bit, start the desalination plants. I mean, it's just impossible to unless you're going to get really good predictions of what's happening. If you knew a few years ago that we were going to have such tremendous extended wet periods, we might have dropped the level of Warragamba. But really, it's impossible, I think, to set in a water storage facility its optimum capacity to be a flood reduction and a storage facility.
So the question is, should we keep the dams at 60%, particularly Warragamba Dam, in case it gets really wet, so that we don't get a whole lot of flood. And if you keep it at 60% and there's a drought, then you're in trouble. So
yeah, I mean, I imagine if I was a desalination plant operator or owner, I'd be pumping for that one. But Wollongamba is designed and operated as a drinking water dam, and as soon as you start to try to have multiple uses, like as a flood mitigation dam, you start to compromise one or the other of the functions, and so one of the alternatives that people have suggested is actually raising the dam wall, so you have a bit more capacity, and of course there's environmental, cultural impacts on that. But what history shows us that if you do something like that and you've raised the dam wall, you can take out the sting of the middle to large floods, but not the extreme floods. And in the meantime, we've happily populated the Hawkesbury Nepean floodplain with a few extra thousand or 500,000 people because it's safe. And all of a sudden, you get overtopping, and the problem is just bigger and bigger. And there's many examples of this sort of techno-optimism across the globe, where sort of putting up levees and dams, etc., actually ultimately increases your vulnerability rather than reducing it. And what we'll see increasingly, of course, is that that's going to be the taxpayer who's the insurer of last resort, and eventually the taxpayer pays. So the message here, I think, is we just need to be smart. Don't put people and infrastructure in harm's way in these floodplains. Understand that, in fact, these floods are probably going to get worse, significantly worse, over the next several decades. And so we need to be cautious in our locations, even around the edges. And I've been in the media just in the last couple of days about how we need to be rethinking our use of 1 in 100 years, because what used to be 1 in 100 years may actually now be 1 in 50, and in the future it might be 1 in 20, etc. So if we want to do risk management, we need to take into account future likely flood heights as part of that. To not do so would be, I think, courting disaster.
Yeah. Another online one.
Yes, from Ian Anderson, says, what tools are available to individuals and governments to accelerate the reduction of greenhouse? Is a carbon tax an option? And do you think it will restart the climate wars?
So the question is a carbon tax an option, and would it create even more drama? I think that's what he's asking.
Thanks, Ian, for that, and I hope you're feeling better having asked that question. Look, ultimately, every greenhouse gas emission, produced, by our society tends to be sheeted home to one user or another. So the kilos of iron ore, are used to make our fridges and our cars, etc. So ultimately, consumers are where those greenhouse gas emissions responsibilities come back to. Of course, there's a lot of middle men and women in the process. So if you look at that and the analysis that supports that, then you say, okay, well, what can I do as an individual? And there's lots of things you can do, whether it's changing your energy behaviour, turning down the thermostat, etc., or up the thermostat depending on the season. Looking for renewable powered, putting solar panels on your roof, or buying shares in a solar farm, community-owned solar farm. Or changing your diet, etc. So there's lots of things as an individual we can do, which will take the edge off our greenhouse gas footprint. But the really biggest thing, in my view, is push upwards. So push upwards to companies and push upwards to the government and say, sorry, this isn't good enough. I'm not buying your product unless you put greenhouse gas labelling on your product. Tell me and inform me when I'm buying your product what I'm actually producing, or what I'm responsible for in terms of emissions. Pushing up to governments and saying, we expect more clarity, we expect more integrity and accountability in terms of those policies. We'd like to see a lot more extensive policy offerings for us to actually vote on, to actually choose from. And over dinner, we were talking about how vehicle emission standards are essentially a no-brainer, but weren't picked up by the current government in their election platform. vehicle emission standards are essentially where the government says to a particular car manufacturer, you know, across your car fleet, you have to achieve a particular greenhouse gas emission level, or you can't sell your cars here. So they comply very readily, and they, instead of sending gas guzzlers to our shores, they send energy efficient cars and electric vehicles, and they put the price down on their EVs and put the price up probably on their gas guzzlers. And it costs the government basically nothing, and it benefits the consumers by having better vehicles and better air quality. So there are, you know, just that's an example of how we need to have a more expansive discussion, public discourse, and the governments can actually lead that and participate that in I think you know, a very positive way. And so that's the sort of way I think which you can have a bigger impact. It's not through your own greenhouse gas footprint, but it's actually pushing up into the system.
Wow.
I want to ask what your opinion is of America now that the Supreme Court is winding back all their climate change laws, allowing companies to just emit whatever, how that is going to affect the world in the future, really, because they're in the future.
Yep, they are. So when you say, well, you know, what do I think of America? I was actually thinking this little sort of animated film some years ago called Team America. So if anyone has seen that, you'll know America. A sort of a slightly different variation. So obviously that's going to make their challenge bigger in terms of reducing greenhouse gas emissions. So they've taken out a core legislative plank in terms of what they can do. So that's essentially a regulatory approach. It doesn't stop the Congress voting to actually instigate a bit of law which would override or bypass that particular decision by the Supreme Court. But with the current balance of power in the Congress and the Senate, it's unlikely to get through. And with the midterms coming up, that's probably going to get even harder once the midterms go through. For me, there is actually a sort of a bigger, almost geopolitical thing here. And if you look at the long-term trends, there's been a lot of convergence with Australia becoming more like America in all sorts of different ways. And I think these decisions by the Supreme Court should tell us that's not necessarily a good idea, and we should become more independent, and we should go our own way, and we should not try to be a little America in the Pacific. So we need to be identifying those things which are values for Australia, which are not consistent with those things which are being expressed, for example, by the Supreme Court judges, and starting to speak out about those and saying, as a result, we've got a much better country.
Thanks very much, Professor. Really enjoyed the presentation. My question is about the actual measurement of temperature and how urbanisation in particular might be affecting that measure. We have a very good case in Melbourne right now where the measurement used to be at the airport, out in a very open area, and it's been brought in to near the TAFE quite deliberately to up the minimum. So Melbourne doesn't appear to be so cold. Believe it or not, when you think being cold is good for the future of Melbourne. Even global greenhouse.
So
the other question is, how do you account for? Let me just extend it a little.
Just a couple of
weeks ago, we had a serious frost, and I work at the racetrack. It was -7. Melbourne's -3. And that's not at the airport. That's at the place.
So what's the question? We've got to keep moving on.
The question is, how does measurement of temperature in growing urban areas affect the overall average?
Yeah, so there's a well-known effect called the urban heat island, which is if you put a weather station in the middle of a city or a town, you tend to change the temperatures, both the maximum and minimums, but on average you get a slightly higher temperature. And the Bureau of Meteorology do take this pretty seriously, and they have a whole stack of quality assurance type programs to take that into account. I'd be very skeptical about a decision to move, the basis for moving a thermometer from, say, the airport to in the middle of town on the basis that it was going to record higher minimum temperatures, because that would not be part of this decision process as far as I can work out with the Bureau of Met. And if you have questions about that, you should ask the Bureau of Met and listen to their response. They are one of the most professional meteorology organisations in the world, and we're well served by our Bureau of Meteorology in terms of our weather data recording and access to that. In terms of the frost, it's what we call the frost paradox. So in parts of southern Australia and also equivalent places in other places in the southern hemisphere and the northern hemisphere, we have, in spite of, on average, increased temperatures, we're actually getting increased risk of frost for grapevines, other fruit trees, cereal crops, etc. And why this is happening is actually related to climate change. So when we look at our synoptic systems, the big pressure systems, our high pressure systems in the middle of winter, which used to track around about the latitudes of the top end of South Australia, are often now tracking around about Tasmanian latitudes in the middle of winter. And so what that means is those winds, which used to circulate around the Great Australian Bight sort of latitudes and then come over the coast, are now circulating around Macquarie Island type latitudes before they come over the coast. So they're supercooled from that traverse across the Southern Ocean. So when they hit the coast, they're a lot colder than they were. And if you combine this with the long-term average reduction in rainfall, clear skies, you get a really, really primed situation for really bad frosts. So we're seeing an expansion of late frosts in Southern Australia due to climate change for those reasons. So, it's one of those, things that people say, oh, it's really cold and we're getting, more late frosts, so it can't be climate change. Well, actually, it is because of climate change. So Stephen Crimp's actually done his PhD thesis on this. It's available online if you want to read up about it. And there's multiple papers which you can access online as well.
So how do you react to the claim that the IPCC is not actually neutral in all this, but its aim is to genuinely prove that climate change is caused by human activity, and to do so, it cherry picks data and manipulates to make its case?
Well, I'd say that's wrong on several accounts. and one is because the IPCC doesn't produce its own data. What it does is synthesize information from other places. And so as soon as people say IPCC synthesizes data, you know that they actually just don't understand, and they haven't, actually looked at what the IPCC does. So I'm actually the longest standing and most capped IPCC person ever. Maybe that makes me biased, but in fact, I think it makes me experienced because I'm critical of many things that happen in IPCC, but that's not one of the things I'm critical about. So if you actually look at the IPCC authors, any transgression on their independence is actually really, really strongly resisted. So, so I think what you have is a whole bunch of highly professional people who are dedicated to looking for truth, in a sense, in the information, and they do this voluntarily. So everything I've ever done for IPCC is pro bono. It's years out of my life has been pro bono to IPCC, and so I think people need to approach the IPCC with a bit more respect than they currently do.
More questions we never get through them, but Jenny Goldie was interested. She sees that perhaps the Sahara might be better off. The Sahara might be better off, she saw in your maps, but she makes the point. It's said that 50 million people face famine this year, and how much of that is due to climate change and how much to other factors like the Ukraine war?
Yeah, I haven't seen any analysis of that latter part, but I suspect it will come. But certainly the Ukraine war has significantly reduced traded grain supplies, and it's pushed the price of traded grain up. And so Ukraine and Russia typically produce, I think it's around about 30% of the traded grain. Australia produces about 12% on average of the traded grain. So to give us a bit of a feel for the contrast there. And of course, if you've got less of that and the price goes up because, supply demand, the poor people who rely on that simply can't afford it. And so that's why I think we're seeing that influence in terms of poverty and hunger. The reality, of course, is that some places on Earth going through intermittent droughts and other sort of access problems, often due to violence and wars, is there. It's almost perpetual state of humanity, and we as a species need to get our shit together. Frankly, this might have been fine 1,000 years ago. I just don't think it's fine this century. We need to be lifting the whole of humanity, and things like what's going on in Ukraine does not do that. Now, in terms of the Sahara, yes, that map shows a percentage increase in terms of rainfall across sort of Mali, Chad, Niger. But in the Sahara proper, of course, a 30% increase on virtually nothing is still virtually nothing. So I wouldn't write home about it. But for the people who are there, it probably does help.
We'll just have a couple more.
Yes, in your final statement, you said that we face big challenges, but also big opportunities, which was really very similar to the statement that Chris Bowen and the new Labor government was giving, in their election. How do you feel that? Are you optimistic that changes are going to happen under this new government, and that they'll be more consultative?
Look, I haven't spoken to Chris since the election, but I've spoken to him a number of times before the election, in the lead up and over the years, and Chris has a very strong sort of economic drive, and is no fool. Like, he's a tough guy, but when he actually commits to something, I think he really does commit to something. So I think what you'll see is substantial action from this government. It won't satisfy everyone, nor will it go without people having alternative views about how things should be done. But I think you'll see a really big lift in terms of activity on climate change and related topics, so the environment as well. And the very fact that the current government and the Prime Minister has put Chris Bowen and Tanya Plibersek as very, very senior ministers in charge of climate change and energy and environment and water, and put those together, is a very, very clear statement of intent from my perspective to actually deal with these things in a much more integrated way than they have been in the past.
Tony. Thank you very much. The current government, through Anthony Albanese, has made the promise that he will develop Australia into renewable energy certificate. It's great. There's no doubt renewables have come a long way. But I can't see, from what I've heard, that renewables can fill the energy and the heat gap and combine it into a sustainable future for energy in Australia. And the IPCC itself has stated that the world needs to increase double its renewable, its nuclear power by 2050 in order to give it a fair chance of reducing carbon dioxide emissions. Over the last 20 years of renewable development in the world, global usage of fossil fuels has only fallen by 2%. We would have to increase our usage of or establishment of renewables by 7 times by 2030 to achieve that goal without actually providing dispatchable or baseload energy. So my question to you is, could you talk to Chris Bowen pretty quickly, who is opposed to nuclear power, or stated that he is, and also to Anthony Albanese, who was a student activist against the use of nuclear power. Now, look, I think these blokes. That's a good enough question, I reckon.
Yeah, there's a lot in there. So what we're seeing right across the globe is a massive rollout of renewables, and it's not been driven because people are Boy Scouts or Girl Guides. It's because it's cheap, and it's dirt cheap. It's the cheapest form of energy in the history of humankind. There's various studies which demonstrate that. So the question is one largely in that case of economics, and it's also a question about the sort of equity issues that arise from rolling out large-scale renewables. You only have to speak to Charlie Prell about some of the importance of the social factors in terms of location of renewables. In Australia, in spite of the fact that we have gone ahead significantly with large-scale renewables, we would have been far further ahead if we hadn't had a problem with energy policy in Australia for the last decade or so. And so, yes, we've got a fair bit in our system. We would have had a whole whack more if we'd actually been organised in terms of our policy. Now, in terms of nuclear, for starters, IPCC does not make recommendations. We're not a body who's aimed to make recommendations and never were. And so we don't say the world needs more nuclear. What we do is we do scenarios which actually say, if you have this mix of different sort of energy technologies, etc., then these are some of the consequences. You can make your own decision about that. That's what we do. We inform the governments. We don't tell governments what to do. So it's a fundamental, coming back to the previous conversation about IPCC, fundamental misunderstanding of the nature of the IPCC. In terms of nuclear, my standard answer is actually very straightforward. Nuclear is too slow, nuclear is too costly, and nuclear is too risky. So I'll expand those. Too slow. If we actually decided today to build a nuclear power plant in Australia, which is big enough to actually make a difference, we wouldn't have one on the ground till 2040, maybe even 2045. Way too late. We actually have to make big emission reductions in the next 8 years or so. So nuclear doesn't cut it at all in terms of speed. Secondly, it's way too costly. So if you look at total lifetime cost, not including ongoing disestablishment costs, deconstruction of it, and certainly not including the 10,000 years of security that you have to have to look after the high-grade waste, it still costs 5 to 6 times more per kilowatt hour than it would if you actually went for something like coal-fired power, and a lot more than new renewables. So it's really bad thing from an economic point of view. You'd sink huge amounts of taxpayers' dollars in there, and taxpayers would pick up the ultimate cost of deconstruction at the end of its life. And lastly, it's too risky. My first public speech I ever gave was the Lions Youth of the Year contest when I was about year 10 or something, and it was on radiation waste management. And I talked about there was various technologies which are coming up. One of them was SynRock from CSIRO. And all of these years later, an embarrassingly large number of years later, we still have not solved the nuclear waste problem anywhere. And there's lots of promises that we're going to do it next year or with this particular approach, etc., but we still haven't solved it. And so if you actually think about this, if you actually just get a small amount of high-grade nuclear waste, you put it in a speedboat with a bunch of Semtex, you sail the speedboat into Circular Quay, you explode that, you close down the middle of Sydney with trillion-dollar costs for the foreseeable future. High-grade waste is incredibly problematic. You need to have absolutely top-grade security for that for the next 10,000 years. You cost that into any model for nuclear and you would not touch it, not just with a barge pod, but you wouldn't touch it from kilometres away. It's just not a viable proposition, and Australia's making good decisions not to go down that pathway.
In this district, we have proposed 400 megawatt solar farm being supported and rejected by members and leaders of our community. We have fossil fuel cars and EVs. Cars continue to drive us towards fossil fuel solutions. Coal miners who do a different job, but what can they do in their mining district? What resources anywhere are being brought into play and influence to encourage change? What are your thoughts, and how can we do transition better? At a local level, I think that's what he's trying to say.
Just what we work on.
Yeah.
That's a good question.
just to finish, thank you.
So it's a sort of a good question, which we could talk about all night, really. So at a local level, I guess you do have to make, have discussions about the pros and cons of siting of different renewable structures. So clearly, a very large scale solar farm like that is going to take a lot of space, and so you hear lots of sometimes positive comments and sometimes negative comments. Sometimes you say, oh, but that's competing fundamentally with farming type activities. But these days there's agrivoltaics is what's called, and that's being practiced right around the world. And oftentimes farmers are much better off having agrivoltaic systems than either just straight agriculture or straight solar panels. So there's smart ways of dealing with this. You can, in terms of where there is siting of these things, you can make adjacent landowners benefit from the location of it. And so again, you can talk to Charlie about this. And so that as soon as some people get the income flow, the protests die down fairly quickly compared with if they're excluded from that income flow. And in terms of broader sort of local things, is that increasingly across the globe, we are in a race for talent and a race for quality living. And if you actually have a reputation as a town which is actually forward-looking, which provides a really high quality of living, which is on the on the cutting edge of sustainable living approaches and things, you're going to be a much more attractive place for young people to come and for other people to come here, for businesses to come here. And so I think we need to increasingly think about how we make our places really attractive. And that isn't by going backwards to more fossil fuels. It isn't by putting a nuclear power station in your backyard. It is actually by going renewables and using renewable technologies to build new industries and to build new jobs. Now, we've done transitions before in Australia, Newcastle, Wollongong, Yallourn, etc., down in Victoria, and parts of Adelaide and various other places. We actually know a fair bit about how to do effective transitions. But what you have to do is you have to start early, and you have to have a plan, and you have to make sure people know that the government and the people around them have got their backs. And once you've actually got that, you can start to move in a sensible way ahead. The alternative is to not have a plan, and for these businesses to pull out with 2 or 3 years warning, and for people to be really, really stuck. And that's where there's going to be really, really high human costs. We can go down pathways which have human benefits rather than human costs, and we should do so.
Thank you.